In this video, we're calculating the shear stress in a riveted lap joint. In this example, we have two steel plates secured together by three 12mm diameter rivets. The allowable shear stress for each rivet is capped at 15 megapascals. Looking at the cross-section profile, you can see how an applied tension force F will try to slide the plates past each other, creating a shearing action across the rivets. We're going to calculate the maximum shearing force the riveted joint can safely handle. Step 1 is to identify the given information. So we lay out the parameters which are known and convert them into standard SI units. The rivet diameter is 12mm, which is 0.012 meters. The maximum allowable shear stress is 15 megapascals, which is 15 times 10 to the 6 newtons per square meter, and our total number of rivets n is equal to 3. Second step is to calculate the single rivet area. So we're going to calculate the cross-sectional shear area of just a single rivet. Using the standard formula for the area of a circle, A equals pi over 4 times the diameter squared. Plugging in our diameter, which is 0.012 meters, we get an answer of approximately 1.13 times 10 to the minus 4 meters squared per rivet. The next step is to calculate the total resisting area. The total area is simply the number of rivets multiplied by the area of a single rivet. Because this is a lap joint, each rivet experiences single shear. With 3 rivets, we have exactly 3 distinct shear planes resisting the force. Multiplying our 3 shear planes by the single rivet area yields a total resisting area of 3.393 times 10 to the minus 4 square meters. In step 4, going to calculate the maximum permissible force. So we arrange our stress formula so that the maximum force equals the allowable shear stress times our total resisting area. Substituting our values, 15 megapascals multiplied by our total area, gives us a maximum force of approximately 5,090 newtons. So we can divide by 1,000, convert this into kilonewtons. So this riveted joint can safely withstand a maximum shearing force of 5.09 kilonewtons.